Hello all. Today we will go over some problems from our textbook section 5.1 on area between curves. Now in this section we will learn to find the area between curves first by knowing the function and given the graph, and as we progress we will see like in this case here, we will integrate with respect to y. Okay, and what if the graph being broken into sometimes the blue one is above, sometimes the blue one is below, but still the graphs are given, and it gets more complicated as we go on where the graphs not given. Okay, so we need to have some basic graphs knowledge in sketching basic graphs and furthermore. Okay, now let's start. Number one, set up an integral for the area of the shaded region. We have the upper bound here is the red curves, and then the lower one, the one below is the blue one. We are given the name of the functions, and we will find the domain of integration first. So x will be from x equals to 0 to x equals to 2, right? This is x equals to 2 here. Okay, so then for number one, the area is equal to the integral from 0 to 2, the function on the top, which is in this case the red one, y equals to 3x minus x squared minus the curve at the bottom, which is y equals to x. Now since we are integrating with respect to x, then the function has to be solved for y equals. Okay, now then from there, of course, what we will do next is simplify the integrand first. Don't integrate right away. Please simplify first. This will be 2x minus x squared dx. Then we apply fundamental theorem of calculus, the second part, right? This is x squared minus 1/3 x cubed between 0 to 2. That is 2 squared minus 1/3 2 cubed minus 0, right? So that will be 4 minus 8 over 3. That's 12 over 3, huh? So 12 minus 8 over 3 equals to 4 over 3. Okay, but I think I want to emphasize the importance of setting it up properly. Okay, so the top function, this is the one in red. Okay, and then the bottom function, let me color that blue. Where's my blue? I hope this one is close enough to my blue. Okay, this is the blue. Okay, that's the one at the bottom, the lower function, and this is the top function. Okay, that's for number one. Again, focus on the setup. In these questions, the first couple questions, we have the graph is given to us, right? Okay, but what if later on the graph is not given to us? We need to graph them by ourselves. But at least we already know what are the important ingredients to set up the integration. Okay, first the domain of integration, in this case 0 to 2. Okay, and then the top function, bottom function. Okay, now let's see number two. Number two, we have the top function is red, the bottom function is blue. The intersection on the left hand side, they intersect at x equals to 1, right? Okay, so the domain of integration will be between x equals to 1 to x equals to 4. So number two, area equals to integral from 1 to 4 And then the top function is square root of x minus the bottom function is 1 over x squared. I don't think I need to use parentheses anymore there, huh? Okay, but I hope you see the consistency that this is a top function and this is the bottom function. Dx. Okay, we will rewrite that integral from 1 to 4. Let me highlight this first. Okay, integral from 1 to 4 of x to the 1/2 minus x to the -2. When we integrate, this will be 2 over 3 x to the power of 3/2 minus, it's actually plus x to the -1. From 1 to 4. So we input 4 first minus when x equals to 1. But it is a polynomial, quote-unquote polynomial. So when we replace x by 1, we just look at the coefficient. 4 to the power of 3/2, when we compute that, we do the square root of 4 first. And then we cube that. Okay, so we get 2 over 3 times 8 plus 1/4 minus, this will be 5 over 3. Okay, that's 16 over 3 plus 1/4. I hope I don't make this computation. Minus 5 over 3. That's 11 over 3 plus 1/4. What is that? 44, 47 over 12. That's for number 1 and number 2. Now, one of the issue when you, your instructor, me or your other instructor did the lecture in this section, one of the issue is, Thomas, how do we know we will integrate with respect to x and not respect to y? It depends on the shape of the region of integration, of course. Okay, but one of the thing here is that you see the function already given y equals something, right? This is solved for y already. Y equals square root of x, y equals to 1 over x squared. Okay, then we integrate with respect to y because the function, with respect to x because the function is given solved for y already. And in other words, the function fx is a function of y. Y is a function of x, y is a function of x. So we integrate with respect to x. Okay, if, like what we see very soon here below, if the function is a function of y, like you see here, this is x is a function of y, then we think of integrating with respect to y. Okay? From the graph we see here, the domain of integration will be from y equals to 0 to y equals to 1. Okay? The function, the top function, in this case the one to the right, is the blue color. The one below is the red color. So the area for number 3, area is equals to integral from y equals to 0 to y equals to 1. And then the right function, the function on the right is square root of y minus the function on the left is y squared minus 1 dy. Let's take a look. This is the top function or the right function, which means the x is greater. Okay, and this is the bottom function or the one on the left, which means the x is smaller. Now then, to integrate that, we rewrite that first. Integral from 0 to 1, y to the 1/2 minus y squared plus 1. Always, before you really do the integration, simplify the integrand first. You don't know how much time you will save by simplifying it. Okay, what I teach you here still applicable even when you go to Cal 2, Cal 3. I mean, anytime you do math, when we can simplify, we simplify, right? Okay, and then we go on. This will be 2/3y to the 3/2 minus 1/3 y cubed plus y from 0 to 1. It's a quote-unquote polynomial, so when I replace the variable by 1, I will just add or subtract the coefficients in this case. That will be 1/3 plus 1, that will be 4/3. Let me write it on the right hand side to save some space. Okay, now that's for number 3. Number 4, the domain of integration y in this case will be from y equals to 0 to y equals to 3. How do we know, Thomas, that the y here is 3? Well, look at this coordinate here, the y value is what? Right? They must be that one. Is it right? Okay. They implicitly already did the work for us that x equals to y squared minus 4y and x equals to 2y minus y squared. This equation and this equation intersect at what y? Okay, by giving that intersections, they already solve the equation for us. Now, what I'm saying is later on, you may be the one need to do that setup. Okay, you will maybe the one need to do that computation, find the intersection. Okay, but here we have for number 4, the area will be the integral from the y from 0 to 3. Okay, and then the curve on the right is the red curve in this case. That's 2y minus y squared minus the curve on the left. The curve on the left is the blue one. That's y squared minus 4y dy. Okay, let me notate this first. This is the curve on the right. Okay, and then this is the curve on the left, which means the x is smaller. Right? When we integrate with respect to x, we use the higher y to the lower y. Okay, y is the high low, right? Okay, but then when we integrate with respect to y, the x will be, the higher x will be on the right hand side, the lower x will be on the left hand side. This will then integral from 0 to 3. Let me simplify the guy inside first. That will be negative 2y squared and then plus 6y, plus 6y dy. Okay, otherwise we need to integrate 4 terms, right? Okay, let's integrate only 2 terms by combining them. Then when we integrate, we get negative 2/3y cubed plus 2y squared. Actually 3y squared from 0 to 3. When I plug in 3, that will be negative 2/3 3 cubed plus 3 times 3 squared minus 0. That will be, what is that? 9 negative 18 plus 27, that's 9. I think the computation part, once we are done with setting up the integral, we are actually okay. After that, we just apply the integration, right? The key feature in this section is to set up the integral. Okay, we already done 4 examples here. Now let's go further. What happens if the graph sometimes have the function on the top and sometimes at the bottom. Okay, like number 5, for example, here we see that on the left hand side here, the integral will be from -2 x equals to -2 to 0, where the blue function, the blue curve is above, and then to the right of the y-axis we will integrate from 0 to 2, where the red curve is above. Okay, because there is a switch of that, we will break the area into two parts. Okay, we will break the area into, let's call this area 1 plus area 2, where this is our region 1, this is our region 2. Okay, now then for area 1, it will be integral from -2 to 0. Okay, the top function, the function above, that will be x cubed minus 3x minus the function below, that's y equals to x minus x dx. That's area 1. Let me draw a line here so that I have this. Plus integral from 0 to 3 for area 2. No, I'm sorry, from 0 to 2, not 0 to 3. Of the upper bound, the upper function, that's x, minus the lower function is x cubed minus 3x dx. I squeeze this a little bit. Now I combine like terms, integral from -2 to 0 of x cubed minus 4x dx plus integral from 0 to 2 of negative x cubed plus 4x dx. Now, actually from the graph you see that area 2 and area 1 must be exactly the same area, right? So if you happen to have the foreknowledge of that region 1 and region 2 are symmetric with respect to the origin, then you can just integrate from 0 to 2 and then you double the area. Okay, yeah, if you happen to know that, have that in advance. But right now let's focus on how to set up the integration. Okay, so the area 1 and area 2, and then I will integrate, that's 1/4 x to the 4th minus 2x squared from -2 to 0 plus negative 1/4 x to the 4th plus 2x squared from 0 to 2. This will be 0 minus -2. There will be 1/4 -2 to the 4th minus 2 times -2 squared. That's for the first group. Let me group it this way for the first group. And then the second group, that's -1/4 times 2 to the 4th plus 2 times 2 squared minus 0. I hope you see what I meant earlier, that the area for region 1 is equal to area for region 2 due to the fact that they are odd functions, but we are looking for the area, right? We are not doing the integral from -2 to 2. So the area of region 1 equals to the area of region 2. Okay, so this will be negative of, what is that? That's 16 minus, actually, yeah, 16 minus 8. Why I feel like something not right. That's the upper function. That's the lower function. Why it give me negative area, huh? That's correct though. Y gives me negative area. Let me check again. X cubed minus 3x on the top minus x at the bottom. At 0, negative 2. Why it gives me negative area, huh? Ah, my bad. It's 16 divided by 4, so this is 4. Duh. Okay. Plus, now, I'm sorry. The one on the right hand side, there will be negative 4 plus 8 minus 0. So we get 4 plus 4, that's equals to 8. That's the area. Okay, if we want to keep track of the work, let's say this is area region 1. This is region 1 here. This is the integral for region 1. It's just to keep track of the work, right? That's why please organize your work. Okay, you may be smart, and most people are smart, but it is not wise not to organize your work. Really, imagine you throw away your brain out of the window by not organizing it. You know, okay, organize your work. Okay, because if you don't organize, then there will be some amount of complicated work that eventually trigger us making mistakes. Okay, so please listen to me, organize your work. I color it this way so that you see what actually happened. Okay, like you can keep track of what I did here. Okay, but it's supposed to be without this highlight though. Okay, it's supposed to be without this highlight. I hope me doing this kind of highlight does not confuse you too much. You know what, let me cancel them. Yeah, I'm afraid that it confuses you even more. Yeah, okay, but by you seeing me doing the highlight earlier, you know which integral for which region, right? Okay. Now, number 6. This question is a bit special because it forces us to actually do the problem by breaking it up into 2 regions. Why, Thomas? Because on this region 1 here, let me highlight that, the upper bound is the line on the left and the lower bound is parabola. This is the line on the left. Let me call that the green line. Okay, the upper bound is green line and the lower bound is the parabola. Now, to the right of x equals to 1, oops, that's not the one I want to use. To the right of x equals to 1, we have this region here, whose upper bound is actually this red line. Okay? So let's call this region 1 and region 2. Call this region 1 and this is region 2. Then our area will be area of region 1 plus area of region 2. This is integral from x equals to negative 2 to 1, and later on plus integral from 1 to 2. You see what I mean? Okay, now in region 1, the upper bound is this line here, which if I solve for y, I will get y equals to 2 over 3x plus 16 over 3. I start squeezing it too much. Let me move this a little bit to the left so that I have enough space. I just don't like to write too small and you cannot see it. So this is 2 over 3x plus 16 over 3. minus the lower bound is the parabola x squared. Okay, that's region 1. Let me highlight that again so that you can see this is region 1. The upper bound is the line y equals to 2/3 x plus 16/3. The lower bound is the parabola x squared. Okay, that's region number 1. Let's see region 2. The upper bound is y equals to negative 2x plus 8 minus the lower bound, also x squared. Okay, but you see the domain of integration is already different. You know what? I think I have some idea. Like this is the first region, and then this is my second region. And I highlight this much. I think that's good enough for you to see. Right? Now then from here, it's just integration. Okay? From here, it's just integration. Let me squeeze a little bit to the left. So this becomes 1/3 x squared plus 16/3 x minus 1/3 x cubed. From negative 2 to 1 plus integral negative x squared plus 8x minus 1/3 x cubed from 1 to 2. Now anything from here is computation. It's 1/3 plus 16/3 minus 1/3. Oh, they cancel out. Minus when x equals to negative 2. I will just compute it right away. Okay, x equals to negative 2. That will be 4/3 minus 32/3 plus 8/3. Yeah, negative 2 cubed is negative 8. Together with this negative here becomes positive 8. Now that's for the first group. For the second group, let me do it right below that. Oops. That's auto-correct. When x equals to 2, that will be negative 4 plus 16 minus 8/3 minus when x equals to 1, negative 1 plus 8 minus 1/3. So in the first one, I have 16/3 minus 12, negative 20 plus 20/3. That's in the first group, plus the second group, 12 minus 7, that's 5, and then minus 7/3. Okay, so I have that 5, so 16 plus 20 minus 7, that's 29, huh? So I have 5 plus 29/3. So that's 15 plus 29/3. That's 44/3. Or you can make it mixed number also. Okay, I honestly don't worry too much about this part. Like once you're done with the setup, everything after that is like it's just computation. Okay, what I'm afraid is you set it up incorrectly. A wrong setup. Once you set it up wrong, everything you do after that will be pretty much waste of time. Okay, so make sure you slow down on your setup such that when you're done with your setup, you can compute the integration with confidence. Okay, if your setup is incorrect, whatever you do after that will be waste of time. Okay, that's for number 6. Let's go on. We now get into the type of questions where they don't give us the graph. We need to set up the graph ourselves. Okay, number 12. Sketch the region enclosed by the given curves. Decide whether to integrate with respect to x or y. Draw the typical approximating rectangle and label its height and width. Find the area of the region. Well, first we will sketch it first. Okay, we will sketch that. Okay, so let's see. The first one here is x is between -1 to 0. It's in quadrant 2. Let's say this is the x-axis, this is the y-axis. Y equals to 1 plus x cubed. X cubed looks like this, approximately. Okay, so this is y equals to 1 plus x cubed. And then y equals to 2 minus x. So the y-intercept is 2. The slope is -1. So this is y equals to -x. 2 minus x. Between x equals to -1. Oh, okay. So this is x equals to -1 here. To x equals to 0. So the region they want us to take care is only this part. It's this part here. From x equals to -1 to x equals to 0. Right? Okay, so yes, we will just integrate with respect to x. So the area is equals to integral from -1 to 0. The upper function, that's y equals to 2 minus x. The lower function is y equals to 1 plus x cubed dx. Now, you may wonder about this. Thomas, they want us to draw the typical approximating rectangle and label its height and width. What is that? Let me enlarge this a little bit so that we can see better. Okay, what they meant by that is, suppose you draw a approximating rectangle. Okay, let's say this is the rectangle here. Okay, now the width of this rectangle will be our dx. The width of this will be dx. The height will be, this is the height from y equals to 2 minus x to y equals to 1 plus x cubed. Now, the height of that is the difference between these two. Okay? Y equals to 2 minus x is this high here. This is the height, right? Okay? And then you subtract by the height of y equals to 1 plus x cubed. You cut this away. So this is the height they are talking about. Okay, which is this part here. Okay, that's how we know which is the top function, which is the bottom function. Okay, let me bring it back to our earlier one. Right now it becomes very small, right? Okay, but then that's how we set up the integral. Okay, the top function minus the lower function. Let me combine like terms first. That will be 2 minus 1, that's 1 minus x cubed dx. When I integrate, I get x minus 1/2 x minus 1/4 x to the 4th between -1 to 0. 0 minus -1 plus 1/2 minus 1/4. What will that be? 5/4, 3/4. So that will be 3/4. Okay, that's for number 12. Number 16. Number 16. The reason I chose to work on this problem is actually we need to have some exposure to trigonometry, and you are required to be able to graph basic trig functions. Okay, so let's say this is my x-axis and this is my y-axis. Sine x function looks like this. We just need this is pi over 2, this is pi sine, that's sine x. It's actually supposed to look like this, right? And more. Okay, but I only graph this far because the other one, this is y equals to 2 over pi x. That's the slope, right? Okay, that's the slope. Now, that will give us this line. When x equals to pi over 2, the y value is 1. So it refers to this line here. They intersect there. Okay, the region of consideration is this one. Let me enlarge this. I think my graph happens to be too small. This is the region which we need to find the area. If we draw the typical rectangle, if I draw the typical rectangle, this rectangle here, again the thickness is dx. Okay, but the height will be the height from the sine x minus the height from 2 over pi x. Okay, so that's the upper height, the upper curve minus the lower curve. Therefore, the area will be integral from 0 to pi over 2 upper function sine x minus lower function 2 over pi x dx. Okay, integral sine x is negative cosine x. Integral of 2 over pi x is negative 1 over pi x squared from 0 to pi over 2. Okay, when I take care of the cosine, the negative cosine, that will be negative of cosine pi over 2, which is 0, minus cosine 0. And then minus at pi over 2, that's 1 over pi over 2 squared minus 0. This will be negative of 0 minus 1 minus, this will be pi over 4. I believe so. Pi squared over pi, that's pi. Yeah. Okay. So this will be 1 minus pi over 4, that's 4 minus pi over 4. That's the area. But I actually want to say one more thing. I mean, we are done with the question. We are done with the question. But the following integration will be very useful for you when you go to Calc 2. Please remember this. Okay, please remember this. Very, very useful. This question, what is the integral or the area of the sine curve or cosine curve in each quadrant? So if you have y equals to sine x, okay, and in each quadrant. Now, then you see that the area here is the same to the area in quadrant 2, is the same to the area in quadrant 3, but it is a negative area. Is the same to the area in quadrant 4, but it is negative area. Okay, now what I want you to see is if we integrate from 0 to pi over 2 of sine x dx, this is equals to 1. You can try to compute that you will get that's equals to 1. Okay, it will be best if you can memorize this to speed up your computation once you get to Calc 2. Of course, ask your instructor first once you are in Calc 2, sir or ma'am, if I see this integral, can I just skip the computation and call that 1, because we see this very often, you know. Okay, it will be nice if you can memorize that. Of course, consequently, the integral of cosine x in quadrant 1, that's also equals to 1. Okay, so one of the consequences, for example, then what happened, Thomas, if we have integral from 0 to pi of sine x dx? Well, that's quadrant 1 and quadrant 2. The area is 2. How about integral from 0 to pi of cosine x dx? Believe it or not, that will be 0. Why? Because quadrant 1 for cosine is positive. Quadrant 2 for cosine is negative. Do you see that? Okay, negative area, right? This is negative area here. This is negative area here. I just colored that so that you see the partition. The second quadrant, the third quadrant, the first quadrant. The area in the first quadrant is positive for cosine. The area of the second quadrant is negative for cosine. Okay, the area in quadrant 4 of cosine is positive 1. Okay, now I hope by you memorizing this a little bit, even if your instructor requires you to show the work, you already know the answer, you just need to show the work. Okay, now let's go on. Sketch the region enclosed by the given curves and find its area. This is more challenging, okay, because you are required then to know what the graph look like, right? Y equals to square root of x minus 1. This is the base function. The basic function is square root of x, which looks like this approximately. But then I move to the right 1 unit, right? I move to the right 1 unit. So let's move this to the right 1 unit. Let's say it looks like this. Okay, that's square root of x minus 1. It actually not really look like that though, I'm sorry. Now then, x minus y equals to 1. X minus y equals to 1. So x equals to 1, y equals to 0. Oh, this is y equals to x minus 1, huh? So it actually looks like this. Yeah, it actually looks like this. This is y equals to x minus 1. So our region is this very tiny, skinny, small region. I don't know how to call that, but you know what I mean. It's like this small one here. Okay, I will need to find where they intersect. Okay, well, now we know that y equals to x minus 1, but y also equals to square root of x minus 1. Okay, so when I square both sides, I get x minus 1 squared equals to x minus 1, x squared minus 2x plus 1 equals to x minus 1. Then we go on. So we get x minus 2, x minus 1 equals to 0. So x equals to 2, x equals to 1. X, as we expect, they do intersect at x equals to 1, but they intersect again at x equals to 2. Notice that these are things that was provided to us in earlier part. They give us the graph, right? Okay, they give us the graph, but right now it's not more anymore. So we need to come up ourselves. In fact, we need to come up with the intersection ourselves. Now, then The area, therefore, equals to integral from 1 to 2, the upper function, which is square root of x minus 1, minus the lower function x minus 1 dx. Okay, now how to integrate these? That's a bit challenging, I think. I need to separate that, seems like. Let's separate this. So this is integral from 1 to 2 of square root of x minus 1 dx minus integral from 1 to 2 of x minus 1 dx. Why do you separate that, Thomas? Because square root of x minus 1 is not integrable directly. We need to do substitution there. Long time no see. Yeah, u equals to x minus 1, so du is dx, but the limits of integration, u at 1 is 1 minus 1 is 0, u at 2 is 1. So that the first integral here will becomes integral from 0 to 1 square root of u du. Okay, while the second integral, you can just integrate it right away from there. That's 1/2 x squared minus x integral from 1 to 2. Okay, this is 2 over 3x, I'm sorry, u to the 3/2 from 0 to 1. This is, when x equals to 2, that's 2 minus 2. When x equals to 1/2 minus 1. So this is 2 over 3 minus 0 minus negative 1/2. Is that right? So I get 2 over 3 minus 1/2, that's 4 minus 3, that's 1 over 6. Oh, that's a very, very small region. Okay, actually we can also do integration with respect to y. Let me move this guy away from our path, and I will do it the second method. So this is if I integrate with respect to x. Let's try to integrate with respect to y. I think it's easier because I need to find where they intersect in terms of y. I know y equals to 0 and y equals something. Okay, so if I solve that, let me redraw it then. Let me redraw it. So this is y equals to square root of x minus 1, which is also, if I solve for x, it will be y squared plus 1 equals to x. Okay, then the second equation, the lines, oops, the lines look like this, right? This is x minus y equals to 1, or we can also write x equals to y plus 1. Okay, so x equals to y plus 1 and also equals to y squared plus 1. Do you see that? So cancel the 1, y equals to y squared. Kedabam kedepu, you will get either y equals to 0 and y equals to 1. So our domain of integration with respect to y will be between y equals to 0 to y equals to 1. Okay, so the area will be integral from 0 to 1 respect to y. Now, the curve on the right hand side is this guy. This is the curve on the right. And this is the curve on the left. Right? So the curve on the right will be y plus 1 minus the curve on the left is y squared plus 1. Okay, combine like terms, I get integral from 0 to 1 of y minus y squared. Easier to integrate, huh? Okay, that gives us 1/2 y squared minus 1/3 y cubed. From 0 to 1, that's 1/2 minus 1/3, that is 1/6. The same answer we get, but a lot easier to do. Okay, you may wonder then, Thomas, how do we know which integration is better? Okay, a lot of exercise, trust me. If I tell you the shortcut right now, which I do, okay, you may not go through the sufficient exercise, the sufficient experience for you to come up to that own intuition. Okay, but the rule of thumb usually is that we avoid square root. We prefer dealing with square. Of course, it depends on the shape of the domain also. Okay, the shape of the domain here seems to be easier to deal with. I mean, it's easier to deal with either way, with respect to x or respect to y. But because respect to x involve radical, okay, and we need to do substitution in between, okay, so it's better for us to do with respect to y. Okay, but again, how do we know in advance? It's nearly impossible if you have a very limited exposure to setting up integration and doing integration. Okay, in other words, that kind of shortcut, you only know, it's not a shortcut though, it's not correct to call the second method here a shortcut, but it's a shorter way to do that. Okay, and me telling you what is the shorter way to do that, you will not feel that it is shorter until you really do it both ways. Okay, so I do encourage you to do it both ways. Okay, oh, I should have said this in the beginning. How do you actually use my lecture videos when I go for examples like this? The best way is you see me doing it, and then you pause the video and try to do it on your own. Okay, so after I finish number 1, you pause it, you try to do it on your own, and then I do number 2, pause it, you do it on your own, like that. Okay, and then after you're done with the whole lecture videos, me going over everything here, then you try to do problems on your own as well. Okay, that's for number 22. Let's see number 25. Notice that I usually don't do odd numbers, but if I do, it means there could be something we can learn from there. Okay, number 25, we have y equals to square root of x. That's easy. Square root of x looks like this. Okay, and y equals to 1/3 x looks like this approximately. But x is between 0 to 16. I don't know where they intersect though. I don't know where they intersect. Let me write it properly first. Y equals to 1/3 x, and this is y equals to square root of x. Where do they intersect? So y equals to square root of x, which is 1/3 of x. If I square both sides, I get x equals to 1/9 x squared. So 9x equals to x squared. When we solve that, you will get x equals to 0 and x equals to 9. So they intersect at 9 here. However, this question wants us to find the area enclosed by the given curve. Unfortunately, here we want the x up to 16. So there's a switch in between, huh? Call this region 1 and call this region 2. Okay, so the area equals to area in region 1 plus area in region 2. That is integral from 0 to 9. The upper function is square root of x. The lower function is 1/3 x dx plus region 2. The area is from 9 to 16. The upper function is 1/3 x minus the lower function square root of x. So remember, you always set it up, sketch the graph first. Now, if I usually have this kind of students in my class, I don't mind students asking me this kind of question, but some of them is actually come with a bad spirit in the sense that, Thomas, is there anything I need to know so that I don't need to sketch it? No, there's no way. Okay, there's no way for you to know this without sketching it. Okay, no way. Okay, you may be smart and you don't need to sketch it. Okay, but that is not wise. Okay, I emphasize this very often in my class. Okay, you can be smart, but you won't grow if you are not wise. Okay, smart means you can process things faster. That's all. Okay, but if you don't study, you have nothing to process. It's like in our computer, it's like processor and the data, or the hard drive, the solid state, where you get the data. Being smart, you only have the processor, but you don't have data to process. Okay, it's just like empty can. You know, you have a can, a good container, but nothing in there that you can use. Okay, a smart person is like that. Okay, a wise person have the processor, may not be that fast, you don't need to be super smart, but you fill your brain, you fill your knowledge up with important and relevant knowledge. So you have something to process. Okay, please don't think like shortcut only. There's nothing to be proud of if you can do problems fast. You can be proud if you can do it right. Okay, so emphasize on correctness and structure. Okay, more than just like, oh, I don't need to write this, I don't need to write this, I get the right answer without doing it properly. Nothing to be proud of that. Okay, please listen to me. I think I have enough experience in teaching to tell you that I have seen enough smart people, but they cannot grow because they have that arrogance that they don't need to do what other people do. No, please don't think that way. Okay, you can be smart, but you cannot grow if you don't fill up your brain, your knowledge with what you're supposed to do. Okay, but once we set this up correctly, anything after this is just over x to the 1/2. This becomes 2/3 x to the power of 3/2 minus 1/6 x squared from 0 to 9 minus 1/6 x squared minus 2/3 to the power of 3/2 from 9 to 16. Okay, when I plug in 9 in the first group, okay, oh, should be plus here, sorry, minus 0, that's for the first group, right? And then the second group, that's 1/16 squared minus 2/3 16 to the power of 3/2 minus, ooh, that's a long one, 1/6 times 9 squared minus 2/3 9 to the power of 3/2. What will this be? The first group, 9 to the 1/2 3, 27 divided by 3, 9, 18 minus 81/6 divided by 3, 27/2 plus, this is 256/6 divided by 256 is 128/3 minus square root of 16 is 4. 4 cubed is 64. 128/3 is, oh, they cancel out. Minus 81 over 6, that's 27 over 2 minus 18. Oh, this cancels out, and these two are actually the same numbers, huh? Yeah, this guy here is the same with this guy here. So 36 divided minus 27 is 9, 9 over 2. That's 9 over 2 plus 9 over 2, that's equals to 9. Let's go on with number 28. Again, we need to find the area enclosed by the given curves and find its find the area. So number 28, the graph of cosine x. Cosine x looks like this. Approximately looks like this. Okay, from 0 to pi only. Oh, okay, so up to here only. This is pi over 2. Now, how about 1 minus cosine x? Let me remind you again with transformation. Cosine x looks like that earlier. Negative cosine x looks like this. You flip that upside down. This is negative cosine x. Okay, now then, what happens if I add 1? This is 1 plus negative cosine x, right? That means I will move this up 1 unit. I will move the green color curve by 1 unit up. How to do that? I'll move this up 1 unit. Like that. This guy get carried over. This is pi over 2 here. Okay, this is 1. So the maximum here is 2, right? So what happened is I need to find, there are 2 regions between 0 to pi. This is region number 1, this is region number 2. The intersection here is something we need to look for. Where do they intersect? Okay, so the first thing I will do is to find the intersection. Let me do it right below that. So y equals to cosine x, which is also 1 minus cosine x. When I solve this, I get 2 cosine x equals to 1. So cosine x equals to 1/2. And we can see the intersection is in the first quadrant. So x is pi over 3. Okay, as x is in quadrant 1. Okay. So now we see that this is pi over 3. Now, then, with that said, how about the area? The area equals to the area in first region plus the area in the second region. Not second quadrant, second region. The area in the first region, that's integral from 0 to pi over 3 dx. The area in the second region is from pi over 3 to pi dx. Okay? Now let me put in the function. In the first region, the upper function is cosine x. The lower function is 1 minus cosine x. I squeezed this in a little bit, I'm sorry. And for the second region, the upper function is 1 minus cosine x. The lower function is cosine x. Next, I will simplify as usual. this is 2 cosine x minus 1 dx plus integral from pi over 3 to pi 1 minus 2 cosine x dx. Now that's the setup. Okay, that's the setup. How to compute that? It's something I assume you are able to do already. Okay, I will still compute that, do that for you though. I will still do the integration for you, but focus on the setup. Okay, please focus on the setup. The second region is this part here. Okay. Now then this is equals to 2 sine x minus x from 0 to pi over 3 plus x minus 2 sine x from pi over 3 to pi. Plus this is pi minus 0 minus pi over 3 minus 2 sine pi over 3. It's a bit to the left, to the right. Let me move it a little bit to the left, so that when I save it, it's not too far, becomes too small. Okay, so sine pi over 3 is radical 3 over 2 times 2, that's radical 3 minus pi over 3 plus pi minus pi over 3 plus 2 plus radical 3. Okay, so we have 2 radical 3 and then pi minus 2 pi over 3, that's pi over 3. Okay, that's the area. In fact, we can say that even further, that this is the area of the yellow region. Okay, and this is the area of the blue region. Okay, we can simplify a little bit though, the blue one, but that's if you see how I actually break it up, right? You can trace which one is which one. Okay, you can trace which one is which one. Okay, that's for number 28. Let me go on a bit more. I wonder how many more questions I want to do. That's all, huh? Okay, 2 more questions. Number 34. This may be very hard. I don't know, but I'm sorry, I'm a bit tired. Okay, so let's see. That's y equals to 1/4 x squared. Oh, okay, that's parabola. So y equals to 1/4 x squared. And y equals to 2x squared. That's still parabola, but it's skinnier because we stretch that vertically. So this is y equals to 2x squared. And then x plus y equals to 3. So that looks like this then. The region bounded by this. This is a bit... X is positive. Okay, x is positive. I need this one. I need this one. I need this one. So it will be this guy, because x is positive. Otherwise, then we'll have another one meeting here. So imagine that it goes like this, and it goes like this. Then there's another region here, bounded by those 3 curves, right? But we need x positive, so we don't need that part. We don't need this part. We don't need this part. Okay? We don't need that part. We just need this one. But dang, it means we have to break it up into two regions. We need to see where they intersect here, where they intersect here, Okay, so the first one is, call this point A and call this point B. So solve for A. I just need the x component. So I get y equals to 2x squared. At the same time, the y equals to 3 minus x. Right? This is y equals to 3 minus x. So 2x squared plus x minus 3 equals to 0. Can I solve that by factorization? Is it doable? It's 2x and x. Plus 3 minus 1. Okay, so x equals to negative 3 half. This one not applied because x is, we want x to be positive, right? And x equals to 1. So they meet here at x equals to 1. Okay, and then we will solve for x in B. The coordinate B, that's the intersection between y equals to 1/4 x squared and y equals to 3 minus x. I will multiply by 4 and then solve. So x minus 6, x minus 2, x plus 6, is it right? So x equals to 2, x equals to negative 6, that's the one we don't use. So from there we see that this is x equals to 2. Okay, so we get the intersection. Now I have to say that if your pre-calculus, your algebra is very weak, this is the point where you cannot move forward. I'm sorry. Solving equations is required from algebra, and I don't think it's possible for a student without algebra background to do calculus. Maybe I don't have enough teaching experience for that. Just call it that way, right? But I challenge you to show me a student who can be successful in calculus without knowing algebra. So in other words, what I'm saying is like, no, you cannot avoid algebra. Okay, go back to your algebra and see how we solve an equation. Okay, but once you are able to do that, then we will see that, well, okay, let's call this region 1 and this is region 2. In region 1, the integrals from 0 to 1, the upper bound is 2x squared, the lower bound is 3 minus x. And then in region 2, the area is integral from 1 to 2. The upper bound is, I'm sorry, the first one, the lower bound is not 3 minus x. The lower bound is 1/4 x squared. My bad. It's not that one. It's in region 2. The upper bound is the line, and the lower bound is 1/4 x squared. Okay, you can pause the video anytime you think I'm too fast. Okay, and then I combine like terms first. In my first one here, that's 8, so that's 7/4 x squared dx plus integral from 1 to 2 of 3 minus x minus 1/4 x squared dx. This is 7/12 x cubed from 0 to 1 plus 3x minus 1/2 x minus 1 over 12x cubed from 1 to 2. Okay, the first one, 6 minus 1 minus 4 over 6. Huh? So that's 8 over 12. So that will be 2 over 3. That's when x equals to 2. When x equals to 1, 3 minus 1 half minus 1 12. I just do it fast. 6 minus 1 minus 3, that's 2. Okay, minus 2 thirds plus 1 half plus 1 12, that's 7 12. Let me show you what I actually did. This guy together with this give me this guy. This guy by itself. Okay, and the 2 comes from 6 minus 1 minus 3. That's how I get that 2. Okay, do your own computation though. Okay, so this will be 14 over 12 plus 24 over 12 minus 8 over 12. What will that be? 30 over 12. Reduced by 6, that's 5, 2, 2.5. Okay, I'm sorry, I kind of like a bit rushing right now. I'm a bit tired, so check my computation though. Don't trust me too much, but I believe my setup is correct. Okay, you see the principle, right? This is the domain of integration, integral from 0 to 1. Okay, upper function, lower function, right? And then for the same region, for the second region, you do the same thing. Okay. That's correct. Okay, the last one, which I may not do in full. Evaluate the integral and interpret it as the area of the region, sketch the region. So what happened is we have these two functions. The first function is square root of x squared. Square root of x plus 2. So square root of x moved to the left 2 units. And the function y. Y equals to x. This is y equals to x. And this is y equals to square root of x plus 2. Now, we want to integrate from x equals to 0 to x equals to 4. I don't know where they intersect. I don't know where they intersect. But I assume the 4 is somewhere here. Okay, now when they put the absolute value there, means they want to take the positive difference. Okay, that becomes the area in the first region. So that integral represents the area of the first region plus the area of the second region. Okay, we need to find where they intersect first. Y equals to x equals to square root of x plus 2. Let's solve this. So I get x equals to 2 and x equals to negative 1, which does not apply. Okay, so this number here is 2. Okay, now then this integral from 0 to 4 of absolute square root of x squared plus 2 minus x dx has to be computed. We cannot integrate a function with absolute sign, at least not directly, not analytically. Okay, so we have to break this up. Which function on the top at what interval? From interval 0 to 2, the function at the top is square root of x squared, at the bottom is x. And then between 2 to 4 is the line is on the top and then the square root at the bottom. That's what it looks like. Okay, now then when we compute, this will be integral from 0 to 2 square root of x plus 2 dx, because I need to do substitution. Okay, minus integral from 0 to 2 of x dx plus integral from 2 to 4 of x dx minus integral from 2 to 4 square root of x plus 2 dx. Now, I will not do this in full. You can do this. This one and this one here, easy to do. You can do it, right? Okay. Now, but for this part here, and this part here, you need to do u substitution. Okay, so u at 0 is 2, u at 2 is 4, and u at 4 is 6. Okay, so the integration then becomes integral from 2 to 4 u to the power of 1/2 du minus 1/2 x squared from 0 to 2 plus 1/2 x squared from 2 to 4 minus integral from 4 to 6 u to the 1/2 du. Okay, this guy for here, this guy for this, this guy for this, this guy for this. Okay, now instead of being lost in the details in the integration, I assume you are able to do this integral. My concern is, can you look at this integral here and then think about, okay, well, in this interval, when will square root of x plus 2 above? When will y equals to x above? The best way to do it is sketch the graph. Okay, and then you find where they intersect. Together with the sketch of the graph, then we will know which function above at what interval. Okay, then you can go on, proceed with setting up this integration here. Okay, so this part here is not doable without this graph. Okay, only from that graph you can translate the original question into this, the sum of these two integrals. Okay, now you can compute that yourself there, and this is where I will stop my recording.